Hello and welcome to another Ginger Mathematician video, where today I'm going to go through some GCSE maths on factors and prime numbers. So if you're in Key Stage 3 as well, year 7 to 9, you'll also find this very, very useful as well. Let's get started. So a factor, well, what is a factor? Well, it's simply a number that divides exactly into another number. So a number that goes into another number. So we'll do a couple of examples. We're going to write down all the factors of 20 and all the factors of 90. Now, the best way to do this is by doing it in pairs. Now, the best thing to do is to start with 1 times 20. So those two numbers multiply to give me 20, so they both fit into 20. And as we go through, do them in pairs. So we started with 1. Let's go to our next number, 2. Now, can we multiply 2 to get to 20? Yes, we can. We can then do 10. Then we think about 3. Does 3 go into 20? No, it doesn't, because 2 plus 0 is 2. 3 doesn't go into 2. Then we look at 4, and we go, well, does 4 go into 20? Yes, it's in the 4 times table, 4 times 5. Now, we can stop at this point, because our next number would be 5. We've already done 5. And once we go beyond that, we've already counted the numbers already. So we can write down for certain that our factors are 1, 2, 4, 5, 10, and 20. Now 90 works in the same way. We start with 1 times 90. Always start with this one. And then we look at 2. Does 2 go into 90? Yes, it does. 2 times 45 gives us 90. Then we look at 3. Well, does 3 go into 90? Yes, it does, because 9 plus 0 is 9. 3 goes into 9. And we think, okay, 3 times 30 works. Now we look at 4. Does 4 go into 90? Well, if we're not sure, we can always use our bus stop method. 4 goes into 9 twice, remainder 1. 4 goes into 10. Well, that goes in also twice, but we get a remainder of 2. If we get a remainder, it doesn't go in exactly. So 4 doesn't work. Now let's check 5. Does 5 work? Yes, it does, because it ends with a 5 or 0. Again, we can do a similar method here of using the bus stop method to check what that number is. 5 into 9 go 1, remainder 4. And 5 goes into 48 times. So we get 5 times 18. And we can keep going through these processes. So if we go with now 6, now does 6 go into 90? Well, 2 and 3 do, therefore 6 does. And you could do a similar bus stop here. I'm going to skip ahead slightly and write down 15, but you can certainly check this to make sure that is the case. Does 7 go into 90? No, it's not in the 7 times table. Does 8 go into 90? Not in the 8 times table. But I think we can all spot here that 9 times 10 equals 90. At this point, once we go beyond 9, that's 10, but we've already had 10, so we know to stop there. So our factors are 1, 2, 3, 5, 6, 9, 10, 15, 18, 30, 45, and 90. So the key method here is to go through in pairs to make sure you've got all the factors. You'll see in the example, all the factors. So have a go at the questions down below. Can you work out all the factors of the numbers that you see? Okay, so I'm going to go through some answers here. So 14 is 1, 2, 7, and 14. Okay, so if you've got that right, give it a tick in your book. 24, well, we can go 1, 2, 3, because 3 times 8. 4 times 6 works, and we can then work backwards. So we get all those numbers there. So make sure you check what you've done to see that you're happy with the process we just did. Now, a question they can often ask you here is the highest common factor of two numbers. Now notice, in my previous example, we actually worked out the factors of 20 and 90. So I'm going to write those down. So let's write down 20 first of all. So let's see what we had. 1, 2, 4, 5, 10, 20. 1, 2, 4, 5, 10, 20. 90 we've already done as well. So we've got 1, 2, 3, 5, 6, 9. Lots of factors here. 3, 5, 6, 9, 10, 15, 18, 30, 45, and 90. So we have all our factors then, and we just got those written down, and we're looking for the highest common factor, so the highest number that they share. So let's see if we can find that. So I'm going to circle this in green. What's the highest number that they share? Well, they don't share 20, but they do share 10. So 10 is going to be our final answer. So highest common factor, write out those factors, and then find the highest number that they share. So we're going to do the next one. We're going to try and be a little bit smarter about how we do this. So 24 we already did here. So we have 24 is 1, 2, 3, 4, 6, 8. This is an alternative way of being able to do this question. And 60 has a lot of factors. It has a lot of factors. So instead we're going to work backwards. So we're going to look at 24. Does 24 go into 60? Well, it doesn't, so that's not going to work. Does 12 go into 60? Yes, it does, because 12 times 5 gives you 60. So this is a very nice, neat way. You can use one of the lists and then compare the numbers going from biggest to smallest. So it saves you a little bit of time going through what we've just done. Okay, so have a go at the questions below. Notice I've used numbers that we've already found factors of, so it's going to save you a little bit of time. Give yourself 5 minutes on these. Okay, hopefully you found all the factors. So I'm going to give you some answers here. So 20 is the highest common factor here. Notice 20 goes into 20 and 20 goes into 60 as well. So let's go for this one here. Well, this is going to be 4 because it's the highest number that are both factors. So make sure you've used what we've done before. And with this one here, again, we can use our factors of 20. Does 20 go into 72? No, it doesn't. Does 10 go in? No, it doesn't. Does 5 go in? No, it doesn't, but 4 does. So we can also write 4 here. So this is a nice speed up way of actually working out factors. On to prime numbers. So the definition of a prime number, it has exactly 2 factors, 1 and itself. So the first question to ask here is 1 a prime number? Well, it isn't, because 1 only has one factor, which is 1. So when we have our list of prime numbers in a moment, 1 is not actually a prime number. Now, is 91 a prime number? So the way to do this is to go through from 2 and beyond and check if they go in. So 2 doesn't go in. 3, well, let's check. 9 plus 1 is 10. 3 doesn't go into 10, so that doesn't work. Okay, it needs to be an even number, so 4 doesn't work. 5 doesn't work because it doesn't end in a 5 or 0. 6 doesn't work because 2 or 3 do not go in. So now we're on to 7. Now there is no rule for 7, so we then go to our trusty bus stop method to work out whether 7 goes in. Well, 7 goes into 9 once, remainder 2. 7 goes into 21 3 times. So it is not a prime number, and the reason is 13 times 7 is equal to 91. Okay, so we do need to check all the numbers that go into it, and don't just stop at 6, do carry on and make sure you've checked all those numbers. Now for this, where do you stop checking numbers? Well, if we take the square root of 91, and think about what that could be, it's going to be between 9 or 10. The square root of 81 is 9, the square root of 100 is 10. So it's between 9 and 10. So once we've checked 9 and 10 as factors, we can stop at that point. So have a go at this. Okay, I'm not going to give you the answers because it's going to help you in the next slide. But have a think. See if you can work out if these are prime numbers. Okay, well, we're going to find out on our very next slide. So I've done a grid from 1 to 54, and I'm going to go through how we work out which numbers are prime and which are not. Now, 1, we already decided is not a prime number. Okay, so we're going to put a cross through that, and we're going to start at 2. Okay, so let's think about 2. Any number a multiple of 2 is not prime. So I'm going to shade in every multiple of 2. Now what do I mean by multiple? In the 2 times table. So 2 and 4 and 6 and 8 and 10 and 12 and so on. So I'm going to shade all those in grey. But 2 itself is a prime number. Okay, so I circle the prime number and I shade in, or cross out, all numbers a multiple of 2. Now I do the same process with 3. I circle it because it's a prime number, and then I cross out all the numbers that are multiples of 3. So 3, 6, 9, 12, 15, 18, 21. So notice all these numbers down here are multiples of 3. So I'm going to cross them out. Then we go on to 5, and I'm going to cross out all multiples of 5. So 10, 15, 20, 25. So we're going to cross that one out. And 30, 35, I'm going to cross that out. 40, 45, 50, 55. So now I'm going to cross out that one and that one. I think that's everything. So I advise you carry on this method and see if you actually make a list of the first 27 primes in your book. I would recommend knowing these off by heart. Now I'm going to circle them now for you. So 7 is prime, 11 is prime, 13 is prime, 17 is prime, 19 is prime, 23 is prime, 29 is prime, 31 is prime, be a little bit careful, 37 is prime, 41 is prime, 43 is prime, 47 is prime, 49 is not prime because of 7 times 7, so hopefully you did not fall for that trap, and 53 is also prime. These are really useful numbers just to know off by heart, so when we do some more complicated things, then we have those to hand. Any whole number, this is an amazing thing about numbers, can be written as the product of prime numbers. So the prime numbers and just multiply it together, like you see on the board already. Now, when we've got small numbers, we can kind of do this in our head. So notice 6 is the same as 2 times 3. Are both of these prime? Yes, they are. So we have our answer. 10 is equal to 2 times 5. Are both prime? Yes, they are. 15 is equal to 3 times 5. Are they prime? Yes, they are. 21 is 3 times 7. Are they prime? Yes, they are. 18 is equal to 2 times 9. Is this prime? No, it isn't. Aha, little trick, because 9 is the same as 3 times 3. Okay, being sneaky. 8 is equal to 2 times 4. Are both these prime? No, they're not. 4 is equal to 2 times 2. So we get 2 times 2 times 2. Is this 70 prime? Well, no, we can do 7 times 10. Are 7 and 10 prime? Well, 10 is not prime, so we can rewrite that as 2 times 5. Now, so far, we can do this just by looking at numbers and doing it from there. However, for bigger numbers, you need to draw a factor tree. So we're going to do 2 factor trees, 180 and 225. And from there, we can work out the product of prime factors. Now, when I do a factor tree, what I recommend is find 2 numbers that are quite close to each other, as that will save on your branches. Lots of people do this by doing 2 times 90 and keep dividing by 2. What I would recommend to do here is try and find numbers that are fairly close. For example, 18 times 10, because it ends in a 0. From there, we can then break it down into 3 times 6, or 2 times 9. 10 is equal to 2 times 5. Notice we circle the primes now, so 3 is prime, 2 is prime, 5 is prime. 6 is not prime because it's equal to 2 times 3. And then if we write this out as a product of primes, well, we have 2 2's, so we go 2 times 2. And then we have 2 3's, so 3 times 3, and then times 5. Now, some of you may know already, you can write this now as 2 squared, because we have 2 2's. And we can write 3 squared, because you've got 2 3's. And then we can write 5 as well. 225 we're going to approach in the same way. Notice 2 doesn't work in this case, but we do like to try and find numbers that multiply to give us 225. Now we can use a nice trick here. Notice 25 is a number to think about here. Well, 25 times 4 is 100. 25 times 8 is 200. So 25 times 9 is equal to 225. Try and find numbers that are close together. Now, if you want to divide by 5, that's absolutely fine as well. You'll get exactly the same answer at the end. 25 is not prime. It's equal to 5 times 5. And 9 is not prime because that's equal to 3 times 3. But all these numbers are prime numbers. So we circle them. And then we can go, well, 225 is equal to 3 times 3. And then 5 times 5. Remember, this word product of prime factors, product, means multiply. So you have to put multiplying in between. You can also write this as 3 squared times 5 squared as well. So you can write it in this index notation, which is very, very nice. So I'll give you a moment. See if you can have a go at writing the numbers you see on the left-hand side as a product of prime numbers. Takes a bit of practice, but then just spend the time going through it nice and carefully. I'll give you the answers to a couple just so you're on the right track. Okay, so let's do 90. So 90 is equal to 9 times 10, which is equal then to 2 times 3 times 3 times 5. So well done if you got that one there. If we take 81, that's equal to 3 times 3 times 3 times 3. That's a lot of 3s. And that's equal to 3 to the power of 4. So well done if you've got that as well. If you're liking the content, then do think about liking and subscribing. It does support the channel and helps me to know, do you want more videos like this or do you want other kinds of videos? The more support I get, the more those kind of videos I do. Right, last slide to talk about today. So all combinations of prime factors are factors themselves. And this is something that often gets overlooked. So let's take 90, for example. It's a nice number that we've talked about before. So we want to find out the factors of 180. Notice if I just add on an extra 2, so if I copy out what's on the board there and just multiply it by 2, that gives me 180. You can check this as well. So 5 times 3 is 15, 15 times 3 is 45, 45 times 2 is 90, 90 times 2 is 180. And what I'm saying here is that all combinations of these factors are factors themselves. Now we start with 1 and 2, 3 and 5, so all these numbers here. And now I do combinations of them. So 2 times 2 is 4, 2 times 3 is 6, 3 times 3 is 9, 5 times 2 is 10, 5 times 3 is 15. So I've done all the combinations of 2 of them. Now I'm going to do the combinations of 3 of them. So 2 times 2 times 3, that's equal to 12. 2 times 2 times 5 is equal to 20. And I've done all the 2's now. So 2 times 3 times 3 is equal to 18. 2 times 3 times 5 is equal to 30. And I'm just thinking if I'm missing anything, so you have to do this systematically as we go along. So we've done 2 times 3 times 3, that's 18. 3 times 3 times 5 we haven't done, which is equal to 45. Have I missed any? I don't think so. And then we do combinations of 4 of them. So we've got this one here. So 2 times 2 is 4, times 3 is 12, times 3 is 36. And can we do some more combinations? Yeah, we can miss out a 2. So we do 2 times 3 times 3 times 5, that's 90. We've got that already. Have we missed any combinations? 2 times 2 is 4, times 3 is 12, times 5 is 60. I don't think we've done 60 yet. And of course we've got 120 itself. So notice one of the benefits of doing prime factors is that you can actually do combinations of them and then you can slowly work out all the different factors of quite big numbers as well. Okay, have a go at the questions that you see there. I want you to find all the factors of 60, 225, 250 and 36. And think about it nice and carefully, so make sure you get every single number. Okay, and I've put all the factors below so you can check that you've got those numbers. The key thing is, for example, with E, this is equal to 2 times 2 times 3 times 3. That's the product of prime factors. And then you do all the combinations. So you've got 1, 2, 3 to start with. 2 times 2 is 4. 2 times 3 is 6. 3 times 3 is 9. 3 times 2 times 2 is 12. And then 18, which is 3 times 3 times 2 is 18. So you can check you've got all the factors, okay, of numbers, which is a pretty tricky skill to do. Okay, hope you enjoyed the video, and again, please leave a like and subscribe if you want to see more videos like this, and I'll see you on the next video. All right, bye-bye for now.